I'm Logan Ramsey with East Idaho News, and I'm here with Mike Poland, the scientist in charge at the Yellowstone Volcano Observatory. Thanks for sitting down with me to talk with me.
Yeah, my pleasure.
I wanted to sit down and talk with you after the Biscuit Basin explosion that got a lot of people talking, and I'm sure got a lot of people worried once they saw it. So I want to start by asking you, what was it that caused the Biscuit Basin explosion?
Well, this was a hydrothermal explosion. So it was wholly contained within that very shallow layer that's really just beneath the surface where all that hot water is circulating. Now, there's a lot of silica that's dissolved in the water and it can precipitate out. It kind of coats the conduits, sort of like how old plumbing in a house can sort of, get clogged by all the mineral deposits. Same thing happens beneath the surface in Yellowstone. And it can seal off areas and that allows pressure to build. You get boiling water and steam that starts to accumulate. Eventually, that pressure builds to the point that it cracks the rock. And when that happens, you can get a hydrothermal explosion. And so that's exactly what happened back on July 23rd. That was one that might be of a size that perhaps occurs every decade or so on average.
Okay.
Hydrothermal explosions that are smaller occur several times a year in some part of Yellowstone.
Yeah. Do you guys get questions from people if they see like smaller ones of that? Like, I don't know. I doubt that every time this happens, it gets as widely seen as this one was.
Yeah, this was absolutely the best recorded one that we know of. Occasionally, there will be people that ask a question, but I noticed something different. There's perhaps a hole in this place or a crater or some rocks that came out or someone noticed something in a webcam or something like that. That's how some of these events are sort of
Yeah.
discovered. It's oftentimes, happens in the backcountry. And so no one saw it, no one was there. And it's only noticed when a hiker or a geologist who's out there, who's been there before, happens to notice a new deposit that wasn't there the last time they visited.
Okay, yeah. And so that also separated this one is that it was a really impressive example that was caught on camera and
Yeah, I
documented.
mean, it happened in summertime, in the middle of the day at a heavily visited geyser basin. So it really was, the conditions were right for people to see this. The conditions were also right for it to pose a really incredible hazard, just given the timing and the location.
Right. And with this being Yellowstone, a lot of people I'm sure wondered once they saw that, is this any indication of volcanic activity?
Yeah, I mean, I think that's a natural question because there aren't a lot of videos of this sort of thing happening in Yellowstone. And like I said, the conditions were just right for this thing to get a lot of attention, and rightly so. But it is really related to this hot water plumbing system and how conduits get sealed up and so forth. It's not really a reflection of anything happening at deeper levels. There was no contact between magma and water that triggered this explosion, which might, I think, a lot of people might have jumped to that immediate thought that there was magma rising up. If that were happening, we would have seen far different signals. There would have been a lot more seismic activity and ground deformation and gas emissions, things like that. The signs would have been a lot different. And this really was a pretty classic example of what happens in these really unstable plumbing systems when you get subtle variations in pressure change that can trigger these real big steam blasts.
Right. And what are the tools that you use to the methods that you use to monitor that and keep record of that?
So we use a lot of different tools to monitor activity at Yellowstone. The most well-known might be seismic monitoring. We've got about 46 seismic stations spread all throughout the region. That many stations allows us to see very, very small earthquakes pretty much anywhere they occur in the national park and the surrounding area. We also have about 30 continuous GPS stations. Those are running 24/7 and they're monitoring how the ground rises and falls. And you can detect really tiny fractions of an inch changes in how the ground is moving. We also measure gases, both via continuous measurements in a few places with sensors that are in place. And we sample gases and waters pretty regularly from many of the basins around the park every year. And we look for changes that might reflect something that's happening beneath the surface. So we also use satellite monitoring. Satellites can tell you how the ground is moving, but we also do thermal monitoring from space. There's a number of satellites that have the ability to basically see the temperature of the ground. And we can use that to identify changes over time or areas that might heat up or cool down. That was the way we've discovered some hotspots that we wouldn't have otherwise known about because they were way in the backcountry. So that satellite monitoring is really useful.
Right. Well, and when you say hotspots, do you think you could clarify more for people what that means?
Yeah, so a hotspot viewed by a satellite is not necessarily something that's absolutely, really blazing hot. It's just an area that's a little bit warmer than the background. In some places, it could be quite a bit warmer. Even satellites are used to track wildfire activity and detect wildfires. But you can also detect these variations in surface temperature of the ground. So a thermal area, like the area around Old Faithful, which is warmer because of all that hot water beneath the surface, really shows up in one of these thermal images when you compare it to some ground nearby that doesn't have all that hot water nearby.
Right. Okay, cool. Um, yeah, and then I'm also kind of wondering if there's are any of these methods that you've already talked about, or maybe any that you haven't mentioned yet, like new that you're bringing to the table?
One of the techniques that we're really starting to try to introduce to Yellowstone is called infrasound. It's basically acoustic monitoring. And it's looking at very low frequency sound waves, things that we can't necessarily hear, but that go very, very long distances. The first infrasound array of multiple microphones was installed back in September in the Norris Geyser Basin, and it almost immediately paid dividends. We can hear Steamboat Geyser erupting. That's the tallest geyser in the world. We can hear that very clearly. But the other thing we heard with this new array occurred on April 15th. There was a small hydrothermal explosion in the Norris Geyser Basin on that day. And it was unwitnessed because that was the time when the park was closed. It was sort of between their winter to summer operational transition. But it left a small crater and it left a very large signal on this infrasound array. So it was a loud event, but completely unwitnessed. And we might not have even known that it happened, or certainly when it happened, without that infrasound array. So we're trying to put more of the infrasound out so we can hear more of what's happening in the Yellowstone region.
Okay. Cool. And I'm also wondering, when people get talking about this or see different things with Yellowstone, um, what are different things that happen that people mistake for indications of volcanic activity? And the first one that comes to my mind is anytime there's like some sort of earthquake in the area anywhere near Yellowstone. You address that and other things that you've seen.
Yeah, I think that's the most common is seismic activity. And that really can show up in a couple of ways. So for example, when there's a seismic swarm, which is a bunch of earthquakes that occur kind of very quickly in time and in the same general space, so a little cluster of earthquakes. Sometimes I'll get a lot of questions, but there's a swarm in Yellowstone. Does that mean it's about to erupt? That's the way Yellowstone behaves. It's a very swarmy place. And it's not because it's very active volcanically. It's rather because there's all that hot water moving around in the subsurface, and there's a whole bunch of faults that are cutting the region anyway. The Tetons have a large fault associated with them, and that trends right into Yellowstone. There's some faults in western Montana that come right down into Yellowstone. It's a very active tectonic place. So you mix all that water in with all those faults, and you're naturally going to get a lot of seismicity. So very little of the seismicity is actually related to the magmatic system.
Okay.
I think the other thing is the large earthquakes. Are those big earthquakes related to some sort of volcanic activity? And there again, it's the tectonic system. The classic example of that is the magnitude 7.3 Hebgen Lake earthquake. It happened 65 years ago this month in August of 1959. That was due to fault motion on some of these big tectonic faults that run through the region. It wasn't related to the volcano.
Okay. Okay. Yeah. Are there any others that you can think of that are, like that get talked about as like, oh my gosh, the super volcano is about to erupt?
I've seen the seismic is really the most widespread. Occasionally, I'll have people ask me about ground deformation, and there are a lot of misinterpretations about ground deformation. For example, I hear a lot of people say, "Oh, the ground is rising in Yellowstone." Well, it's not right now. The ground has been subsiding since 2015, but it rises and it falls. It sort of does this cyclically. Now, we know based on looking at geologic evidence that the ground overall has gone down by about 100 feet in the last 10 or 15,000 years. But over the last 100 years, we know it's gone up sometimes, it's gone down, usually at the rates of about maybe an inch a year or so. And so we haven't had any uplift since 2015, but there's still these strange rumors out there that the ground is rising, or it's rising at some alarming rate. And that kind of cracks me up because there's all these GPS stations out there. It's a pretty easy thing to check and demonstrate that that's not true. So that's another pretty common misconception.
Right. And something else that people hear often is like,
Mhm.
and a super eruption is imminent,
Right.
or that we're overdue. I don't know if
Yeah.
necessarily they say that it's imminent. They'll be like, we're overdue for a super eruption. Is that true? Is it about to erupt or?
Now, that may be the most common misconception I've heard about Yellowstone, that we're somehow overdue. And I think it's based on the last three big explosive eruptions at Yellowstone. And if you average them, you get about 725,000 years between each event. Somehow or another, somewhere along the line, someone decided that it was 600,000 years between events. And because the last one was 631,000 years ago, we're overdue. Well, that's wrong for a few reasons. One, the math is wrong. Two, the average of just three eruptions is not a whole lot of data to base much on. And three, volcanoes don't work that way anyway. Volcanoes sort of erupt when there's a supply of molten material beneath the subsurface to feed an eruption and pressure to get that stuff up to the surface. And neither condition exists in Yellowstone right now. In fact, we know from passing seismic waves through the magma system at Yellowstone that the magma system is mostly solid. We sort of did kind of like taking an MRI of the Earth, and we can see that there's hot rock down there. But in terms of the melt content of the reservoir, it's maybe 25%. So it's not as if there's even a big molten reservoir down there. It's mostly solid.
Okay. Well, and then this is another thing where like um, everyone talks about the super eruption. Is it possible that there could be different uh I guess maybe the best way to say it is different levels of eruption where like it could be a smaller eruption than
Yeah.
what you would expect or
Yeah, absolutely. The Yellowstone, like many volcanoes, it has different styles of erupting. And the most common style at Yellowstone is a lava flow. And the best example of that, I think, these lava flows are not the thin lava flows that you see on TV that are coming out of Hawaiian volcanoes. They're really, really thick, pasty things, and they're humongous. So when you're standing at Old Faithful and you look all around you, there's high ground all around you. You're almost sort of in a bit of a hole at Old Faithful. Everything around you there is a lava flow that erupted since the last time Yellowstone had a huge explosion. And there have been a couple of dozen or so of these lava flows that occurred since the big explosion that formed Yellowstone caldera. So that's by far the most common form of activity in terms of eruptive activity. And even that's not entirely common. The last lava flow erupted 70,000 years ago.
yeah, and if there's a lava flow, does that throw out like like ash out into the sky, and does that like um cover the area around it or
It can. There are some of those lava flows that appear to be associated with layers of ash, but they're not tremendously thick layers of ash. They would still be very noteworthy eruptions, and anything occurring in, I think, the middle of the United States would be. But they're not these eruptions that are going to deposit, many, many, many feet of ash in any given place. They tend to be relatively thin layers, and the real activity is the lava flow, which could potentially go on for years.
okay. Yeah. I imagine park staff would not want to stay there. Most people would not be coming up to visit Yellowstone if that was the
I
case.
sometimes I don't know. I kind of wonder if a lava flow with no explosive activity. I mean, often there are phases, so there might be a bit of ash, and then that would go away, and you'd have a lava flow that would last for years. I wonder if that might attract a tremendous number of visitors that just want to see that. I mean, there's a lot of people that go to Hawaii to see lava.
True.
Imagine going to Yellowstone to see lava. So I could see that being a pretty strong attraction for some people.
That's actually interesting. I hadn't thought about that. Like, I guess I assumed that there wouldn't be anywhere safe to stand and see it.
But lava flows are hazards that are there are things that you can get away from. And the lava flows in Yellowstone, they would be thick and pasty. They're not going to be moving with tremendous speed. So
Okay.
it's a kind of thing that you could observe. Now, I imagine you shouldn't be too close because these they're almost like piles of rubble that move across the landscape. So there'll be a lot of avalanching of material off the fronts of these things. They're not safe to be real close to, but
Right.
and there is always the potential for sort of an unexpected explosion from magmatic gases that accumulate and things like that. So you wouldn't want to be particularly close, but it's something I can imagine you could sort of view as occurring across the landscape. And you know, people get really into some of this stuff. I mean, people chase tornadoes and hurricanes and things like that, right? So
Yeah.
chance to see a lava flow in Yellowstone. I mean, we're not worried about something like that happening right anytime soon because the magma chamber is mostly solid, but I could imagine if it happened, there'd be a lot of people that would want to go see it.
Oh, that's interesting. I hadn't thought about that. Um, so the big question then I guess is like, so say that, the super eruption, the full thing, worst case scenario, were to actually happen, what would be the indicators that you would see before that were to take place?
There would be some pretty massive indicators. So I mentioned there's this magma chamber that's mostly solid, and you'd have to rejuvenate that and then push this magma up to the surface. So that's going to be associated with a huge amount of seismic activity, right? I mean, there is going to be earthquakes galore, a lot of felt earthquakes. There will be really dramatic ground deformation. I said how the ground rises and falls by an inch or so per year, almost like Yellowstone's breathing. The uplift due to magma rising up to the surface would be dramatic. And you almost wouldn't need instruments to measure it. You'd be able to see places that were rising up. There would be gas emissions that were changing because magma is like a soda. It's got gas dissolved in it, so it gets close to the surface, the pressure is less, and it lets some of that gas out. There would be thermal changes. We'd see them in satellites. We'd see them happening on the ground. And changes in geyser systems would be happening across the park. And that's one of the reasons, another reason I point out that, this explosion at Biscuit Basin is so local and confined to the hydrothermal system right in that area. There's pools right next to that pool that exploded that didn't react at all. And if this were due to magma that was rising up, you would see whole basins changing. So that kind of activity, before an eruption would be associated with really massive changes all around. And here's the cat making his appearance as usual.
Making a guest appearance. Well, and that also makes me like, does that mean that like I'm kind of wondering how many days would that be going on for before it would actually happen? Like how much time would people have to start, like trying to leave?
Um, it's difficult to say exactly, but given that we have this magmatic system that's mostly sort of moribund right now, it's just sort of stagnant. In order to rejuvenate that, it would take possibly years. And so the kind of warning signs we'd get would be pretty significant and pretty long lasting. Occasionally, I have somebody bring up the idea that Yellowstone could erupt tomorrow and we wouldn't have any clue. I guarantee that's not going to happen. I mean, in volcanology, in terms of hazards, we have a built-in advantage over many other hazards disciplines because volcanoes give warnings. Before a volcano erupts, it's got to get magma up to the surface, and you can't do that without creating lots of earthquake activity or ground deformation and gas emissions. There are signs, and a place like Yellowstone that hasn't erupted in 70,000 years doesn't have anything that's really well greased, right, to get magma to the surface quickly and easily. So there would be a long buildup, and it would be pretty obvious.
Okay.
Geologists worldwide would be sort of going nuts, as would, all the people that live and work in and around Yellowstone. It would be pretty obvious changes.
Right. So me at East Idaho News, we'd be covering it. We would be covering that quite extensively.
Yeah, it's very likely you would be feeling the changes that were happening in Yellowstone,
right?
Even in Idaho.
And like possibly running articles like how much time do we have? Like how.
Yeah, I think that's what we would, as geologists, would be talking about is, okay, we see some evidence that Yellowstone is starting to become rejuvenated. What does that mean? And will it culminate in an eruption? That's an important question with a lot of volcanic crises. A lot of volcanoes are restless and then they go back to sleep. So how can you tell whether a volcano that's maybe increasing activity is going to culminate in an eruption, or will it go back to sleep? That's a big challenge in volcanology. It requires a lot of monitoring data, a lot of insight into what's happening in the subsurface.
Right. That's it's really interesting because like I saw a low budget film once in school that depicted a super eruption, and they were very much like it's a all of a sudden like they get some indicators that this is what's going to happen. It happens, it erupts. People don't have any warning. Hard for them to get out. That's almost a more interesting scenario where like people are wondering like, is it going to erupt? Like, should I be moving right now? Do I have the capability to move? Do I just stay here and wait to see? That's really interesting.
Yeah, I think if there were about to be an eruption, and the most likely event would be a lava flow, which would be relatively low impact, given that most of the effects would be confined to Yellowstone National Park. But if you start feeling earthquakes and stuff, I mean, everybody has their own thresholds for what they're willing to accept in terms of risk. But it's not something we're worried about sneaking up on us, because the place is so well monitored, and the changes that would be occurring would be so massive that it's just not something that could be ignored.
Right. Right. Yeah, that's I I imagine there would be a lot of people who would also maybe a little bit too soon like pack up their entire house, everything they can fit in their car, drive as far away as they can, and then find that there's still going to be some time until something like that occurs, if it occurs.
Yeah, quite possibly. But I mean, in the end, for any volcanic eruption, the only defense we have against an eruption, whether it happens in Yellowstone or Mount St. Helens or anywhere in the world, is to not be there when it happens. There's not an engineering solution to stopping eruptions. There may be some ways we can mitigate the effects of eruptions slightly, but it's a bit like a hurricane. The best advice if a hurricane is headed your way is to not be there when it makes landfall. Same thing is true of a volcanic eruption. You just don't want to be there when one happens.
Right. Okay. And then I do want to know also that so like we get these signs for years. We're wondering if it's going to happen. There's that conversation, and then we'll say that it happens. There is the super eruption. Can you speak to what that would look like for the world? What would happen once the super eruption occurred if it
Would definitely be a globally impactful event. Now, in the immediate area of a really huge volcanic eruption, the landscape is just devastated. The area is swept by these ash flows that deposit really, really thick layers, tens to hundreds of feet thick of ash. So you really sort of sweep the area clean in the immediate vicinity. Farther out, you get fall of ash, and the farther away from the eruption you are, the less ash there is. But even small amounts of ash can be very impactful to agriculture, water, electrical grids, and it weights roofs on houses, and then it can cause a lot of collapses in that way, especially if it's wet. Then it basically turns into concrete. All that ash into the atmosphere, especially the stratosphere, the upper layer of the atmosphere, will also block out some sunlight, and so there would be a global cooling that might last for a few years. After that, after it settles out, things would sort of get back to where they were. But we know that this happens from other eruptions that have occurred historically. There are a number of eruptions that have occurred that sort of lowered temperatures by a small amount globally. The last one that really had an impact like that was in 1991, Mount Pinatubo in the Philippines, lowered global temperature by a fraction of a degree or so for a year or two. So these big eruptions, it's not going to end civilization. It's not going to result in extinction. That's another common misconception, is that, well, if Yellowstone erupts or a volcano like Yellowstone has an eruption that big, humanity is going to go extinct. All plants and animal life is gone. No explosive eruption has ever caused an extinction on Earth. Right. Even the largest explosive eruption that we know about, which happened 76,000 years ago in Indonesia, there was a population of hominids, of kind of early humans, a different species, but they were a couple of islands over and they lived through it. It's not going to be easy. I wouldn't want to do it. But it's not going to be the end of the planet. It's going to be globally impactful, but humanity and life will go on.
Right. Okay. Yeah, well, I'm trying to think about anything else that I need to ask you. Is there anything about really anything that I've talked about so far that I guess I didn't ask you about, or you didn't cover that you'd want to go back to and maybe address.
Well, I suppose one thing to let people know is that if they're interested in learning more about Yellowstone geology and volcanic activity, we do try to put out a lot of products. I mean, it's just a fascinating place. Yellowstone is, it's called Wonderland, right? Geologists think of it as Wonderland too. It's just an incredible place. If you're interested in the geology of Yellowstone or hearing more about current activity, research, that sort of thing, we do have a number of things that we try to put out pretty regularly. So we've got a weekly article called Caldera Chronicles, and you can get that on our website. You can sign up to get it via email. You can even get it on USGS Volcano's social media. We've got Facebook and X and Instagram. We also put out annual reports. So if you're curious about, what was earthquake activity like back in 2018? We've got a report that describes earthquake activity and ground deformation and geyser activity. We also put out monthly video updates beginning of every month to talk about what's happened in the Yellowstone area in the previous month. So we try to put out a lot of information. We're also happy to answer questions. So if anyone wants to know more about what's going on at Yellowstone or anything, has questions about geology there, they can drop us a line. Our email is yvowebteam. That's all one word at usgs.gov. We love talking volcanoes, and Yellowstone is just endlessly interesting.
Well, thank you for talking about them with me. I learned a lot of things that I did not know about Yellowstone, actually. Which I mean, isn't surprising. I'm no expert on Yellowstone, but yeah, thank you for talking with me, and thanks for explaining this to our viewers.
Yeah, my pleasure. Thanks for taking the time and asking some good questions.